So our invited talk will be given by Dr. Jing Wan. Dr. Wan is a visionary data science leader with more than 20 years of experience in machine learning, AI, and data analytics. She holds a PhD in computer science from Purdue University and has published 15 plus AI papers in top-tier journals and conferences. Besides her academic contributions, Dr. Wan has also held data science leadership roles across multiple Fortune 50 companies. She currently serves as an associate director at Verizon, where she leads a data science team and delivers significant business value through advanced modeling and cutting-edge data science technologies. So I am really honored to have Dr. Wan here to talk with us and tell us about the data science industry. And I will thank you so much, Dr. Wan. I will give the stage over to her then.
Yeah, thank you, Olivia. Let me share my screen. Let's try share screen top one. Yeah. Okay. Could you please let me know if you can see my screen?
Yeah, we can see it, or I can see it.
Okay, great. Yeah, thank you, everyone. It's my great honor to be here and talk about data science. Today, this is my topic. Yeah, I will first touch about what data science is, and then discuss about different roles related to data science. Then discuss with you about what skills are needed for people to work in data science area, and demonstrate what's the current or previous or future career paths if anyone want to get into this area. And also, I'd like to discuss with you about emerging trends in AI. So in the end, we'll have some Q&A session. If you have any questions, feel free to ask. Maybe some of you have already know what is data science. So the question is, what is data science? So data science is a process that you extract knowledge and insights from massive, noisy data. And once you extract those knowledge and insights, you want to select ones which are actionable and present it to business in an organization to drive any business action, either to help a company have a growth in revenue or provide the best services to a customer. So later, I will give you some practical examples about what we do at Verizon for data science. First, let me take a little deep dive into what areas data science covers. So data science is the intersection of three disciplines. The first one, let's look at the red circle. We call it computer science and hacking skills. Those are skills related to coding, and you find something that other people cannot find from coding. And then the next circle is yellow. Yellow is your math and statistics knowledge. And the third one is a blue circle. Blue big circle is about domain knowledge, some business related acumen, and substantial knowledge or expertise in some specific domain. So these three circles interact together. If computer science and hacking skills interact with math and statistical knowledge, then we have machine learning. So machine learning started from there. That is a orange one. And if our math and statistics cross with domain knowledge, we have our traditional research, kind of like traditional statistical research on some domain, like a biology domain, pharmacy, and other places. If the red circle intersect with a blue circle, that is computer science and domain knowledge put together, we have our traditional software development. But if those software development without any math or statistics knowledge in regulated, then it can become a danger zone for people to drive not valid analysis. So that's why that is cost at purple one is a danger zone. So but if we incorporate with math and statistics knowledge, the danger zone will become a magic zone. That is data science. So this data science actually covers at least three disciplines together. So this is form data science. So let's talk about different method in data science. So data science, nearly now every company has their data science team related to data analyst, data scientist, machine learning engineer, and you can call it. And each company may cover different types of data science based on complexity and the business value. Each of each data science problem can solve, we generally classify them into five different type of analysis. The first one is called descriptive analysis. So what is descriptive analysis? Descriptive analysis to look at the data and understand what happened. For example, at Verizon, my team is responsible for solve the churn problem at Verizon. Churn means people who leave Verizon, who go to other companies as Verizon's competitors. So for my team, look at historical data, look at our last month of data to understand who actually left Verizon. And if they left Verizon, where they go? Do they go to T-Mobile? Do they go to AT&T? Do they go to other carriers? And if they go, when they go, and which particularly they go, and how many lines they disconnect. So at Verizon, we have a phone business of phone services, we have internet services, we have fixed wireless services, we have all kinds of services we can look into and understand what happened. So that is descriptive analysis. Then the next level is that why we understand the symptoms, what happened. We also want to understand why. Why did it happen? Why people leave Verizon? Are they leaving because the current Verizon price is too high for them? They cannot afford? Or did they leave because of the poor network? Or they leave Verizon because they get a bad customer experience. The phone is difficult to activate. So that's the second pillar, diagnostic analysis. We want to understand why this happened. And the third one is goes to even deeper. When we understand what happened now and previously, we want to predict what's the next. So that's predictive analysis. How we do? So based on historical analysis, based on this month's data, previous month's data, and 1 year data, we build a machine learning model. And we know who actually left the company and who didn't leave the company. We can build a model to see, oh, for people who left the company and for people who stayed in the company, what are features different to drive that? So we can build a predictive model to predict who in our customer base will leave next, will leave in the next 30 months, 30 days, will leave in the 3 months, will leave in the 6 months. So that is a predictive analysis. Currently, many organizations, companies, they have their team build machine learning models focus on this predictive analysis. So after we know who will leave and who will leave and when they will leave, the next very important question to answer is that how we can save them, how we can make them stay in Verizon. So that's the next level, prescriptive analysis. Prescriptive analysis means we drive some solution to make sure things won't either will happen or won't happen. So at Verizon, let me still use Verizon. People leave churn in Verizon example. So now we know who will leave, and we know why they are leaving. So we can design solutions to keep them. For example, if a people leave due to the price is too high, recently Verizon may have increased the price, then we can design an offer, discount offer. We can send the offer to them to say, hey, if you stay with us, we can lower your bill for $20 per month. We can give you some bundled offer. We can give you a free upgrade. So these are solutions we designed for specific people. And for other people who are not sensitive about the price, but they will say, oh, my device is not working. Maybe I should get a new device. We can give them a new device. Or if people who has bad networking, maybe we can send some technicians to that people's house to help solve the problem. So these are prescriptive analysis. So usually, before a few years, I think even before last year, we primarily focus on descriptive analysis, diagnostic analysis, predictive analysis, and prescriptive analysis. Until a few years ago, we have Gen AI, we have ChatGPT, we have Gemini. Those are generative AI. So when we have generative AI creates something new, create new content. So in this area, so data science expanded and can do something different. So that is now we know who will leave Verizon, what type of offers we should send to them. We let generative AI to create an email, to create content on email to attract a customer. So customer will be able to see, oh, this is an offer. Oh, what area I can compare the bills. So this is an area that we can use generative AI to create something to attract a customer. So this is a totally new area. And even more, later I will talk about some agentic AI. Agentic AI, that is even more on top of generative AI. So later I will give you some examples. So generally speaking, we have this five types of data science problems and methodologies that we can use to tackle any data science problems. So that is type of data science. Now, I'd like to talk about what is data science life cycle and what are the different roles. So data science cycle started with understanding the business problem. For example, we have a beautiful lady. Her name is Emma. She's a data scientist. She now get into this company, get into Horizon. So she wanted to build a perfect model to solve some big problems. Then she wanted to talk to marketing, a business partner in marketing. Her name is Lisa. She's a business analyst. So Emma talked to Lisa to say, "Hey, Lisa, what's your pain point? If you have any problems that I can use some automation, use AI to help you." Then Lisa will tell her that she has some funding for making a campaign, sending some offers, but she doesn't know. But her funding cannot cover everyone. She just want to send the discount to someone who's really has high risk to leave Verizon. And then who are they? So that is her business problem. Then Lisa will say, okay, I know this business problem can form to a data science problem. Now we're going to identify data. Do do we have data to identify who are those customers and what features of those customers? Then they go to talk to Jake. Jake is a data engineer. He has 20 years of experience working in Verizon. He knows about data. So he talked with so Emma bring Jake talk to with Lisa. So they're going to figure out where is the data. Once Jake figure out, oh, these are we have like 200 features related to customers account that Jake can hand over to Emma for Emma to do some analysis. But this is potential data. That it doesn't mean the data is perfect. Usually, data is very messy and need some exploration. Then Emma go to look at data. She do exploratory data analysis. We call it EDA. So Emma go to check the data to see, oh, we're seeing this every account has 200 features. So among those 200 features, are they all good quality? So Emma will check, oh, if there's any missing values for some features, or some features may have outliers, or some features may be not relevant to this problem. So there's lots of analysis part Emma will do. Once she find a good quality of data, she will use historical data to build a model. She know what the features can fit into model and what she predict. I'm sorry. So once Emma build a model, then she use some metrics to validate the model. She will use some piece of data to build a model, and that model to predict unseen data and check the model's performance like accuracy, precision, recall, F1 score, and other model metrics. And she proved, yeah, yes, with unseen data and the labels, this model can do good job to predict who Lisa should send offer to. And is it done? No, that's not done because there's another team will be involved. That's our model governance team. So model governance team is consists of multiple different parties. They consist of like a legal team because legal want to make sure Emma and Jake, they are not using any data that is not allowed, not shared by customer. Uh, Also, the model governance team want to make sure this model is fair to different groups. This model is not biased based on gender or age group or any ethnic groups. So once they validate the model is valid, is regulated, and then they're going to look for Mike. He's a my machine learning engineer to deploy the model. Deploy model means you took the model that Emma developed and put it into production environment. Then maybe the model is a real-time model that we have streaming coming, or the model is a batch model that will be running every day or every week. So this is a job Mike will do. He was put it in production and make sure the model goes through any security setup and the model is scalable, is valid, and also after the model is deployed, Mike will monitor the model's performance. Yeah, because he want to make sure the model is still doing good job. It's not like deploy the first day is awesome, but next day is crashed. So that is something Mike will do. And also for this whole life cycle, as you can see from number first step to the sixth step, it's a product. It's a product life cycle. So this one we currently at Verizon we use agile style. So then we have a product manager. We also have Scrum Master who can check each steps, who make sure the whole teams are working together, holding hands to hands. There's no one piece is slacking or one piece is leaking. So that is a different roles we have for data science, related to data science. So now I know probably some of you are familiar with data scientist title and machine learning title. Do they have any difference? Do they have any comment? So then I want to talk about that. For data scientists and machine learning, data scientist is a concept that I think 20 years ago we don't have this concept. But later, once data science concept coming, so companies started to recruit their data scientists, and later they recruit machine learning engineers, so they work together. Both jobs has shared skills. They know Python, they know SQL, SQL is another is type of a query language that you can query data from database, and even for Google Cloud GCP environment, we have a BigQuery. Also use a SQL syntax to get the data from database to build a model. And also, both roles need to have data syncing, and they have good communication because communication is always important for any role. And also, debugging skills and continuous learning and adapting to new technology because in data science area it's developed so quickly. Like every year every month there's a thousands of product launched, thousands of models generated. So they need to adapting themselves to new technologies. That's their shared skills. And what are their difference part? So let's first talk about Emma. She's a curious girl, a lady. She has a general curiosity about data, and also she has curiosity about business problem. She has good business acumen. Because if you don't have a business knowledge, you just dig into data, your assumption may be wrong, or your finding may not be feasible for business to take any action. So that's why curiosity and business acumen are super important for a data scientist to start with. And then Emma has a solid math, machine learning, computer science, and statistical knowledge so that she can build a decent model. And the third one, she's very detail focused because she can dig into the data and massive data, noisy data, and can find very details and through the data. For example, if there's any outliers, you can detect. So this need someone to have detail focused. And the next one is like creativity, because from the scientist, data scientist, focus on scientists, no one tell you the answer because no one knows. There's no one knows what we can get from data. So there needs some creativity for trying different model technologies, doing experiments, design experiments, so that you can connect the dots. You can find the gold from the data. And last one is a telling skills. So that is very important because when you find insights from data, we wanted to give insights to our business partners. They are usually, for example, marketers, or they are someone who's in a specific domain. They don't have data science knowledge. They don't have a modeling or coding knowledge, but we need to visualize the good insights to them, to let them to understand and communicate with them, so that we can jointly have join some actionable business decision to help the company. So that is data scientist. Then what is the different skills machine learning engineer will do? Machine learning engineer, from the title, they are more focused on like engineering stuff. So they are more close to software engineer. So they deploy a model, so they are familiar with the product deployment environment. So they usually build an API and use CI/CD, that automation process, make sure our model can run automatically. And also when they put a model into the existing system, they want to make sure that the model and what's all the process, running process is scalable, is reliable. So they are familiar with the overall machine learning framework. Other than just one model, they are familiar with all the architecture, all the systems put together. So usually machine learning engineer, they can quickly master tools because of and solve the problems. So these are common skills and different skills data scientists and machine learning they share. And now, as we just talked about, we go into a generative AI domain. So there's a new type of position called AI engineer. So AI engineer is an emerging new job. So that is kind of combination data scientist and machine learning engineer together. So data scientists, we still build models, sometimes from scratch, sometimes from some pre-trained model. But the AI engineer, they mostly focus on using existing like a large language model, like kind of like a ChatGPT, Gemini, and other large language model to our foundation model to those are pre-trained model to do to just directly use them, and also they have good prompting engineering skills. That is, I think everyone do. If you ask any questions to ChatGPT, different people may get different answer. That's made or you, I'm maybe I'm getting better answer than another person because I'm right I ask it in a right way, in a prompting way. So that if prompt engineer is also something AI engineers can use. And then we also have like a RAG. RAG is a retriever augmented generation. So that is something we can instead of just use a large language model to answer, we can connect the information with some more accurate data, external data or internal data. So that goes to the next level. Agentic AI. That is instead of we just get the answer, we actually wanted to build some agents. They can do action. They can be your assistant. They can book the ticket for you. So AI engineer, they build model, they treat models like building blocks together. They don't go into deeper in the blocks because those blocks is like function. They're more like using those blocks together. So AI engineer, this is an emerging role, and I don't think in the short term it will be replacing data science or machine learning engineer. But you can see that trend. So data scientists and the machine learning engineer, they will merge together and then come into a new roles. This is always happening in data science area. And now we're going to talk about career paths. If you want to work in this data science area, uh, what kind of certificates or what kind of qualification you are needed? So let's first talk about degree. So now, for example, in my team, all data scientists either have a master degree or PhD degree. This is what is current now. But in the future, I don't think that will be always this case because we call it like AI or data science democratization. So that means everyone who has AI tool, for example, ChatGPT, Gemini, they can explore data. They can become some part of they can do in some part of data science job or machine learning engineer job. So that is in the future. The degree we don't specifically need all the degrees, but definitely we need people to understand the model. Otherwise, you can build something maybe dangerous or not valid. But we do see the trend. The degrees may not be necessary because now we all have tool. Also, the age of the people who do data science may be decreased. So now I see many people in middle school, in high school, started to learn machine learning, started to learn deep learning AI. So that is a trend. The next one is major. So as I previously said, 20 years ago, we don't have data science concept like concept, or we don't have data scientist job in the industry. But about 2008, there's a company starting to recruit data scientists. So that data science becomes the sexiest job in 21st century. So now I think it will be outdated job in 21st century. So at that time, uh, we do you remember the three circle together? People from computer science, from statistical domain, or from a double E domain will become data scientists. And also for my previous colleagues and team members, we also have people from biology, we have people from geometry, we have people from pharmacy, from all kinds of different major join. They wanted to become data scientists. They learn and they get some training. They become data scientists. And now um, I think many like 5 years or 6, 7 years ago, we started to have a data science track, data science major either in computer science or in other department. So we have some people trained in data science area. So this is now. In the future, I think because of data science democratization, any we can have people with any major can do data science job. Um, and then subjective as subjects, we wanted to be good at math, coding, prompt engineer. That means you have logic thinking about what you want to ask, and also you have detail. You have good language that you can ask your question, and also different domain knowledge important. And for involving side, um, this area was definitely involving. So I can see this can be two ends, very extreme ends. For example, there will be less people focus on design AI algorithms, focus on, for example, like Gemini, ChatGPT, and GPT, and the other algorithms. They are designed by people, right? We enhance the model. But those are just a few number of people can do that. Maybe most of people focus on applied AI area, and even for applied AI area, because everyone will have that tool. So we don't need very junior people, as you know. Maybe for people who's learning computer science, we don't need a junior software engineer in this job market. It's very hard to find job. Same thing for data science area. Maybe more junior people were less needed. People will need some people has interdisciplinary knowledge, or the people who has some specific domain specific certificates, for example, focus on one spectrum of the data science area. So that is a involving part. And last, I wanted to talk about emerging trends in AI. So, um, we just touched a little bit about agentic AI. What is agentic AI? Agentic AI is that we utilize our existing models, but not just using it. We want to build some agent to do some action. For example, I can ask ChatGPT, give me the cheapest ticket for me to go from Dallas to Hawaii. ChatGPT will search and give me an answer. But for agentic AI, um, I I don't need to get the answer and do the booking by myself. This agent, my assistant, Jean's assistant, can do it. I just want to say, oh, I have a conference in Hawaii on certain day. Please plan for me. And then the agentic AI, they will search the cheapest ticket or search the best time according to my agenda and book the ticket using my money for me. So that is agentic AI. So now many companies focus on this. Even Verizon, we all wanted to see how we can use agentic AI to automate some process, the business for us. The next one is multi-model AI. So that is instead of just using one type of data, we combine text, image, audio, and all kinds of data, sensor data together to let the AI know. The third one is I just touched a little bit about RAG, like uh, not just using large language model, but also we use the model to connect with the company's specific accurate data, domain knowledge to get a more accurate about the prediction results. The fourth one is a physical AI. Physical AI is also word model. Maybe you haven't heard that people say, "Oh, large language model is not the answer to go to common like a common AI, right?" So word model is more promising. So word model is trying to understand the how the actual world, the 3D world is working. So that is very important for robotics or autonomous system to do. So that's a physical AI. Edge AI is to say, oh, how can we use local devices like phone without connecting to Google to cloud to do things. So it's more safer, more privacy. And the last one is not a list, it's a responsible AI. Responsible AI and governance. is that we want to make sure because now if everyone is using AI, we want to make sure there's a we can control the risk. We want to make sure it's a fairness to everyone. We want to make sure this is safety. So that is a five emerging trend in AI, and this is something in short term I can see, but in long term, mm, who knows? So that in long term, that is something you are going to find out and tell me. So I wanted to quote Andrew Wu. He's a famous scientist in the data science domain. He actually the co-founder of the Coursera. So he said a few years ago, he said AI is a new electricity. Uh, just as electricity transformed almost everything 100 years ago. Today, he said, I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. Now it's already several years later after he said this. We can see AI is covering nearly every area, transforming things. So in this area, there's opportunity, there's a turbulence. What we should do? I'd like to quote Peter Drucker's word. The greatest danger in times of turbulence is not the turbulence itself, it is to act with yesterday's logic. Because we know what happened in yesterday, but we don't know what happened in the future. No one can predict the future, but what we can do, the best way we can do is to predict the future is you to invent it. And so let's involve it and invent it. So that closes my today's talk about data science. And feel free to ask any questions you may have.
Okay, thank you so much, Dr. Jean, for that really insightful and clear talk from the insider's point of view about like what exactly data scientists do. Because I know like many people have heard of like the job title like
Mhm.
of data scientist, but not many people like actually like know what they do. So
Mhm.
thank you so much. And I see we have a lot of positive reactions from everyone else here.
Wow.
So does anyone have any questions for her? Okay, I think Sebastian has a question.
Sure, Sebastian, what's your question?
How would someone get started on a data path career,
Especially since it's hard with the
especially since it's hard with the
junior roles.
Sure. So, um, Sebastian, do you like you are learning math, right? Are you also learning some coding? Have you learned how have you learned Python? Yeah, so at least now you have two circles together, right? You have knowledge of mathematics, and for mathematics you wanted to learn some linear algebra, calculus, or other things, and also and for computer for coding part, you can study to learn some concept about machine learning, not just coding, but also you can learn for example, besides Python, you can learn some libraries like scikit-learn, and also uh, you can take some data science courses that maybe there's some data science course designed for middle school or high school. And Coursera is an online platform that you can go to find some relevant data science courses you can know. And then if you learn some concept, you can do some course project. That the course provided, or go to some Kaggle. Kaggle is a platform that provided some different data sources and different business problem for you to explore, and you can compete with other people around the world. So that get some practical experience. So that may be something I would suggest you to start with.
Are you aggressively using third-party AIs at Verizon?
Uh, Not really. I would say yes and no. So, we because we are the data science team, right? We actually build our own AI models, but we do use the large language model like Gemini. So, Verizon use Gemini, the large language model. We have a deep connection with Google, and because our data put into Google Cloud platform, we use Gemini to do some prompting stuff. We can feed our text into Gemini to get some insights there. So we do both. We do our own models or we use existing large language models.
Thanks.
You're welcome. That's a great question. Okay, so Olivia, I know I spent a lot of time. It's already about close to 8 p.m. and then I know you have many other agenda items you want to go through. So for the limit of time, probably if any one of you have more questions or want to know more about data science area, please feel free to let me know. Oh, I saw Emily and Vishal, you raised your hands. Maybe I can quickly answer your questions before we go to talk to the next topic. Emily, how about you go first?
Yeah, thank you so much for your talk. It was really interesting and I learned a
Mm.
lot. And I just want to ask what you enjoy most about your career.
Sure, that's a great question. What I enjoy most is about I'm keeping learning because in this domain, data science domain, I never feel bored because there could be some jobs that you have done for maybe a couple of years, then you are feeling you are doing something repeating. But in data science area, I never feel that because I even feel, oh, if I'm not learning, I will be outdated. So I'm learning something every day from my colleagues, from my coworkers, from my business partners, and also from other one, for example, in LinkedIn, in some like a YouTube. So that is most things I'm enjoying. That I feel I'm keeping. I'm in a cutting edge area, and I'm keeping learning. But the downside is that. If I'm not learning, then I will be outdated. I will feel my knowledge will be useless. So that is something I enjoy, but also have some limitation. So, we had any questions you may have, or maybe I call your name wrong. Uh, it is it Wilhelm, is that the right name? Yeah. So, do you have any questions you want to ask?
Um, is your job really difficult? Like, do you have to stay up for a long time to complete your work, or is it not that difficult?
Yeah, that's a great question. So that depends the project cycle. So now I'm not more in a management role. So when I was a data science practitioner, when I do data science job, so I can have more time to control my time. So for example, I know I have to deliver a model for example, in 2 weeks. I can plan accordingly. What will I do in these 2 weeks? So maybe if I do pretty well, so I will have some time. I don't need to stay late. But if I failed many times and the project deliverable is tomorrow, then today I have to work really hard, really late. So usually, for doing a data science job, you have relatively, I would say you have to work 7 days, or 10 hours per day. It's not like that, but relatively good work-life balance, but still have, I just mentioned, because we have to learn new technologies. Even if you are not working for the company, but you are still fetching the new news and technologies. So it's keep learning. So I would say, for my experience, maybe different company, different roles. Um, the work-life balance is not too bad, but I just speak for my experience. Maybe someone who's working in OpenAI, who get a very high paid, and I need to deliver a model in the next 7 days. Maybe that person is working very hard, stay late. So that's varies. Okay. Okay, great. Thank you so much, everyone. So if you have more questions, you can give a forward question to Olivia, and she can forward to me. I can answer it by email. Thank you.